So just like before, we have to recall some concepts from 4.1 to 4.3. So remember if you had something that did this. We did a bunch of expansions. When we had x plus 3 times x minus 3, we did this. X times everything in the second bracket, which gives us x squared minus 3x times the positive 3 times everything in the second bracket, which gives us this, which gives us 3x minus 9. Now you'll notice in the center of this problem, we have minus 3x and plus 3x. Those cancel each other out, and we're left with the following. And we're left with x squared minus 9. Now, we had originally taken a look at this and said to ourselves, there's got to be a pattern here. We did several of these, and we found that there was a pattern. The pattern was this. We said that the pattern was if I had a plus b times a minus b, or it could have been a minus b times a plus b, we got this, a squared minus b squared, and we called this the difference of squares. And the difference of squares said that if we had a plus b times a minus b, then we have a squared minus b squared. Now, when we talk about factoring something like this, we're actually talking about going this way in the equation, not going this way. Expansion goes this way to the result, and then expansion goes to, and then factoring goes backwards. Now let's move on to the note for the day. So when we talk about difference of squares, we're talking about the difference raised, the square of two things raised to an even number. So we have ax to an even number minus z, where z is a perfect square. So let's take a look at some problems that we have here. Now I need you to remember our original equation was, our final equation was a squared minus b squared. And that was equal to a plus b and a minus b. So it goes backwards in that direction. So in that case, what I have to do, if you'll notice, our square term for a is an a in both of those linear terms on the right side. So we're actually taking the square root of a. And for the b, we do the same as well. And then we just repeat them and put a plus and a minus in between. So let's do that for this next problem. If I take a look at this, x squared, what you have to do is you have to imagine you take the square root of x squared, and that gives us x. Then we take a look at the square root of 81, and that gives us 9. Now, when you see something like this, something squared minus another number, you try immediately to see if you can use this pattern that we have up here. It saves us a lot of work. Otherwise, we'd be doing factoring by grouping or the Berry method. And sometimes we get tired of doing that. So this basically represents a shortcut. So if I'm doing this, I take the square root of x minus 8 squared, and the best part about it, if I have a minus sign in between, it means that this is a difference of squares. All right, and we can use that on our problem here. So all we have to do is write, well, x in both brackets. And we have our 9, so we're going to use 9 in both brackets because we square root both 81. And then one of these is plus and the other one is minus. And guess what? We're laughing like Larry. We got it right. Now, we can do the same thing for our next problem here. We take a look at the square root of 4 of x to the 4. So let's do that. When you take the square root of 4x to the 4, well, the square root of 4 is 2. The square root of x to the 4 is just take the 4 in our exponent and divide it by 2. That's what you get. So we end up with x squared, which is fine. And then we look at 49. So we take a look at the square root of 49. Square root of 49 is 7. My goodness. I think we're good to go. And notice the minus sign in between. When you get better at this, you just recognize it immediately. And you just end up writing the following. 2 brackets. And in the first bracket, you're going to put 2x and 2x in the second bracket. And then you're going to take the square root of 49 and put it in the second bracket, at the end of the second. And then 1 must be plus and 1 must be minus. And you're done. Now, let us do the third problem of the day. We have 15x squared plus 24y squared. So the first thing that you do is you look at it and you say to yourself, hey, there is a greatest common factor in here. Let's do that first. We might have a problem though. So let's take a look at this. So if we did this problem, we pulled out a 3. What's left inside our bracket is 5x squared plus, not 24, but 8y squared. And it looks like we're actually done. There's nothing else we can do. There is no perfect square. There is no square root for 5x squared that comes out nice. And there is no square root of 8y squared that comes out nice. So we are done.